Okay, and number one, we had to find the mean of the distances here. Okay, so to find the mean, you had to add up all of your data to find the sum. And if you added correctly, and you should show your work for this, you should have gotten 1,328. The second step for finding mean is dividing by the number of pieces of data. So we had 1, 2, 3, 4, 5, 6, 7, 8 pieces of data, which would give you a mean of 166. Now you want to check if that's reasonable or not. Is 166 between the smallest and largest piece of data? And it is, so that makes sense. On to number two. For this one, we also had to find the mean, and it wanted us to round to the nearest tenth if necessary. So that would be one place after the decimal if needed. So again, we're going to add up all our distances. You should have gotten 88 and 8/10 for the sum of your data. And then again, divide by how many pieces of data there are. So we had 1, 2, 3, 4, 5, 6, 7 pieces of data. So the sum of our data divided by 7. And for this one, you should have gotten 12.685, and it asks you to round to the nearest tenth. So our tenth position is the 6. To round, you look right next door. Your bossy neighbor, if they're a 5 or above, it says give that tenth a shove, and they are. So our mean is going to be 12 and 7/10 rounded to the nearest tenth. So remember, for mean, the sum of all the data divided by the number of pieces of data. Number 3 was the same, except now your data was on a dot plot. So you had to get this data off of the dot plot by listing it. That's the easiest way. So 1, 2, we had 2 3s, 2 4s, 2 5s, a 7, a 9, a 10, 2 11s, and 2 12s. And then you had to find the sum of all that data. If you added that up correctly, you should have gotten 99. Then you had to count the number of pieces of data, or the number of dots, and there were 15 of them. So 99 divided by 15 is going to give you exactly 6 and 6/10. It says rounds to the nearest tenth, which you didn't really have to. Moving on to the second page. This one was the most popularly missed question. Remember, when we're trying to reach a mean and we have an unknown piece of data, we have to take the goal mean, what we want to get to, multiply by the total number of pieces of data that you want to have. So in this case, 1, 2, 3, 4, 5, 6, and then subtract the sum of the data that we already know, sum of the known data. So in this case, our goal was a 92. There were 6 total scores, and the sum of my data would have been, adding those together, didn't take notes on this, let me re-add. 87, 92, 93, 88, 94 would be 454. So now I just need to solve that equation. 92 multiplied by 6 gives me a total of 552. Subtract what I already have, 454, and we end up with a 98. So she would need to score a 98% in order to get to her goal of a 92 by her 6th quiz. Okay, on to number 5. What happens to the mean if 91 is added to the set below? So first you had to find the original mean. So add all these together. So the sum of those was 494. And there was originally 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So divide by 8, and you would have gotten 61.75. It did not say how to round it, so I took 61.75. I took 61.8. I even took 62 because it didn't indicate that on the test. I'm just going to put 61 and 75 hundredths down right now. Then it says, what if 91 was added? So if I add 91 more, my new sum is 585. And my new total pieces of data is 9. So 585 divided by 9 gives me a new mean of 65. So the score would change from about a 62 up to a 65. On to number 6. The data set shows the total points that Lucy scores in 5 basketball games, and they wanted you to find the mean absolute deviation. So the first step would be finding the mean of the data. So we needed to add all her data together, and you get a sum of 100 divided by 5 pieces of data gives you a mean of 20. And now we can use our chart to help us. I put her data in order just to help organize it. List my mean. I'm just going to put an arrow down. And then find the distances. Simply subtracting, dropping the negative if there was a negative sign. So this gives us our distances of 4, 2, 2, 3, and 5. Now to find the mean absolute deviation, we're going to find the mean of our distances. So I'm going to add all my distances together, and you get a 16. Divide that by the number of pieces of data, which again is 1, 2, 3, 4, 5 pieces of data, which gives you a mean absolute deviation of 3 2/10. On to number 7. Now we have 2 different people, Murray and Brian, who are reading and the number of pages, and we have to find their mean absolute deviation. So for these, I'm going to first find the mean, add them all together. And for Murray, I got 301 for the sum, divided by 7 pieces of data, gives us a mean of 43. My pen is going a little slow. For Brian, same thing. I'm going to add them all together, and I got 301 for him as well. And he had 7 pieces of data, so he had an identical mean of 43. Now we have to find the mean absolute deviation. So list out your data. And for Brian, next I'm going to find the distance from my mean. So I'm going to fill in a 43 all the way down for both of them. And I need to find the distance 43 is away from each piece of data. So for Murray, we had a 7, 3, 2, 1, 1, 5, and 7. And I simply got that by subtracting the data from the mean to find the distance, dropping the negative sign if there was one. Same with Brian. I'm going to do the same thing. We had a distance of 15, 12, 5, 1, 0, 4, and 29. Okay, so now that I have my distances, the MAD is the mean of the distances. So once again, a lot of finding mean. I need to add all my data together, divide by the number of pieces of data. So for Murray, I had a sum of 26. There were 7 pieces of data. And if you divide that, you get about 3.71, and it keeps going on, and it did not say what you had to round to. On to Brian, if I add all those together, I get a sum of 66. He had 7 pieces of data, divide that by 7, and we get about a 9.43 if you round it. Now we have some questions to answer about them. So taking a look at all that information. The first one says, which sentences are true? Choose all that apply. Murray's mean is greater than Brian's. Actually, their means are exactly the same. They both have 43. So the first one would not be true. The second statement, Murray and Brian have identical means. Yes, absolutely. They both had 43, so that would be true. The third statement, Murray's MAD is 3 7/100, when rounded to the nearest hundredth. That's what I got, so yes. On to the third statement, Brian's MAD is less than double Murray's MAD. This is not true because if I doubled Murray's MAD, I wouldn't get that. And last but not least, Murray's data is skewed by the presence of an outlier. So when I look at Murray's numbers, they're pretty close together. They are not skewed. However, if it would have said that Brian's is skewed, I would say yes, because Brian is a 72. That does not fit in there at all. So Murray's data is not skewed, but Brian's is skewed. So therefore, I did not select that as my answer. Okay, moving on to number 8, another mean absolute deviation. So again, first I had to find the mean by adding everything together, and you would have gotten a sum of 600. Divide by the number of pieces of data, and we have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. And 600 divided by 8 gives us a mean of 75. So 75 is going to go down the center there for my mean, and I'm going to list all my data out. After I list all my data out, I'm going to find the distance. Each piece of data is away from the mean by subtracting and getting the distance. If I get a negative, I drop it. So we have 21 away, 17, 13, 5, 1, 9, 11, and 35. And to find the mean absolute deviation, I'm going to, again, add all those together, divide by the total number of pieces of data. So when I add them all together, I get a sum of 112. There were 8 pieces of data, which gives me a mean absolute deviation of 14. On to number 9. Number 9, I'm now given a dot plot, and I had to organize the information, which is basically take the information and list it out so it's easier to work with. And I'm not going to list it all out because my pen is kind of dragging here, but you would list it all out. And to find the mean, we're going to add it all together and then divide by the number of dots or the number of pieces of data. So when you found the sum for this data, you should have gotten 1,259. There were 15 dots or 15 pieces of data, which would give you a mean of about 83.93. Again, it didn't say where to round to. For the median, you had to cross off the lowest, the highest, the lowest, the highest. And of course, I don't have it all listed, but you would find that there's an actual median. There is a middle that is exactly at 84 because there was an odd amount of data, so you did have a middle. Now we have to figure out which of these describe the data. So the first one says there's a gap at 80 and 81. There is no data at 80 or 81, but that is not considered a gap because it's not between dots. It's basically just the beginning of the number line where there doesn't happen to be any data. So that is not considered a gap. If I had a dot, if it went down to like a 79 down here, then, and see how I added that blue dot, then that would be considered a gap, but that is not there. The next one says there's a cluster between 83 and 85. I'm going to say yes to that because a cluster, they are all kind of together in that area. There is a peak at 84. That's true. The peak is the same as the mode. The most amount of dots are at 84. The median is at 84. That's true. That's what we found for our answer. And last but not least, the mean is 85. That's not true. We got an 83.93. Okay, and on to number 10. So we have the same line plot again, but now we're looking for the best measure of center. So the first thing I'm looking for, do I have any outliers? Is there anything that sticks out by itself? And my answer is no. There's no outlier. So if there's no outlier, I'm looking at this one. No outlier. This one, no outlier. And I'm not sure about the last. Let's read them. So the first, the mean is the best measure of center because there's no outlier. That is true. And the fourth choice, the MAD is the best measure of variation because there's no outlier. That is true. And just to read the last one, the outlier greatly affects the median and interquartile range. That would be true, but there is no outlier, so we would say no.